Hello everybody, I hope you are having a fantastic day. I'm having a fantastic day because I'm getting to unbox a benchtop power supply. I was actually in the market for a second one of these when the people from Circuit Specialist reached out to me and asked if they could send one to the channel, and I said, heck yeah, you can send one to the channel. The one I have right now is this one from Amazon. It is a Tech Power TP 3005T. It is a 30 volt 5 amp power supply. Fantastic power supply. I just need multiple voltages sometimes, and wanted a second one that I could put around the office, and they offered to send me this, and as you can tell, the box is considerably bigger than what the other one came in. So we're going to do an unboxing, and then I'm going to spend some time with it, and I'm going to give you my unbiased opinion. My first opinion is that this thing is massive. So we're gonna pull it out of the box and see what else is in there, and then I'll be right back. Okay, the first thing I can say is holy frick. All right, I'm gonna put these two next to each other just to give you an idea. And this is a massive, massive power supply. So this thing is 0 to 30 volts, 5 amps times 2, and then it has a 2.5 volt slash 3.3 slash 5 volt at 3 amps. So it's actually a triple power supply. In other words, you can do 0 to 30, 0 to 30, and then 3.35 or 2.5 volts coming out of the middle. So the middle ones aren't as adjustable, but it's a third voltage coming out of this thing. So we're gonna go ahead, and for your excitement, we're gonna go ahead and do the peel times 2. Okay, so I have had this thing on my bench for a couple of weeks now, and I've had this one on my bench for a couple of years now. So I'm ready to give my opinion. I don't think it'd be fair for me to just get this thing in, run through it for a couple of minutes, and then start blabbing. I want to actually use this equipment. I want to understand it, and I want to share my opinion. So this is what I've got. We're going to break the review down into a couple different sections. The first one is the user interface and the user experience. What's it like to use these things on a daily basis? What do I like? What do I not like? The second one involves accuracy. Now we're going to look at accuracy from a maker perspective. I'm not using $100,000 worth of equipment to test the accuracy. I'm talking about accuracy from a basic maker perspective. And the third one is just the overall value proposition and what I would change about these things and stuff like that. So without any further ado, let's get started. Now, the goal of the review is not to review this one, but this is the basic everyday bench power supply that a lot of makers would have. There's another version that's more of a switching power supply, but if you want an actual regulated transformer-based power supply, this is the type of thing that a lot of makers have. This is what I started with. And overall, I like it. Same thing, 30 volts, 5 amps. But what I don't like about it is the user interface. So in other words, if I want to change the current, then I have to come in here and click this, and I rotate through, and you're just kind of going through here, and I just don't like this style interface. If I want to come back here, then I got to rotate through these things, and I just find that stuff a little obnoxious to use. Bouncing through these menus, the beeping and all that kind of stuff. I've actually thought about just taking it apart and killing the buzzer altogether on it. It's that obnoxious. Now, this one, on the other hand, I do like the user interface. It's a little different. It has dials. Some people would prefer to actually have numbers to be able to punch in 13.57 volts. But the way this works, if you notice here, we've got a coarse adjustment and a fine adjustment. So if I come down here to, let's just say 2.5 volts, and I want to go to 2.65, then I can come in here and mess around with the fine adjustment. And so you can get there. It's, you know, it's not hard. You don't have to move very far to get up to 2.9. So you have to be a little careful when you're using these things. They do jump around a little bit, but overall, it's not too hard to get it dialed in to what I want to get it dialed into. Same thing goes for the current, except there is not a, which I can't actually adjust the current right now because I don't have anything flowing from it. But you can adjust the current with just one knob. There is no fine on your current limiting. And just to help you understand, if you've never used one of these kind of power supplies before, you'll notice that we have CV and CC, and it's basically the same thing over here. We have CV and CC. So when you're putting something out, you are either going to be putting out a constant voltage or a constant current. And so let's just say that I have a light bulb hooked up to this thing and it's going to want to draw 2.1 amps, which I'll do a little bit later. If I were to set this thing to 13 volts, but then only say it can draw 1 amp, then it's going to drop the voltage down so it's actually only drawing the maximum of 1 amp. Maybe I can demonstrate that real quick. Okay, so I've hooked a car light bulb up to this thing, and you can see that I'm allowing it to draw roughly an amp. I didn't sit there and really dial it in, but because it can only draw an amp, it doesn't really matter how high I put this voltage because it will not be allowed to draw more than an amp. In other words, you can control one of the two variables is absolutely fixed, and so you're not going to run away with too much current as long as you've set the current at 1 amp. Now, as you can see, I'm going to go on the fine side here and I'm going to adjust the voltage. Again, nothing going on there. So if I want to, let me lower the voltage back down. If I want to come up here and say you can draw 2 amps, now you'll see that once we've hit the point where we're not being limited by the number of amps that we have, we're in constant voltage mode. And so I'm drawing 4.7 volts, 1.2 amps. Now the amps aren't really limited, so that's not having an effect anymore. So we can come up here and let's get it up into the 12 and 13. So we're going to get up to 13 volts. Now, if I were to say that this thing's only allowed to draw 2 amps, you'll see it'll start dimming down and the voltage is going to drop. So I'm either in constant current or constant voltage mode, depending on which one I want to be in and what I'm trying to control. So that concept might be a little bit foreign, but as far as I understand, that's pretty much how all of these power supplies work. Now, looking at the user interface here, again, this is 3 power supplies in one. It's a little weird also. You'll notice that the middle thing here, this 5 volts, 3.3 and 2.5 is over here. And then you've got 1, then you've got 2. So you're actually 3, 1, 2. Now, one of the neat features about this thing is that not only are these 2 full 30 volt power supplies, but you can set them up to be parallel or serial or independent. Now, 99.999% of the time, I'm going to use it as 2 30 volt 5 amp power supplies, but you could also do 60 volts at 5 amps or 30 volts at 10 amps if you were to change the mode of the power supply. So overall, really couldn't be easier to use. You could say that dialing things in exactly what you want is a little tricky, where on this one, it's not really going to float around with this style. You know, you're 6 and you push it and you're done. I would say for the types of things I do, I prefer the dials to the clicking the buttons and all that kind of stuff, but that's just a matter of personal preference. So I just finished making a separate video about the ripple coming out of an ATX power supply. And to just kind of recap, when you're taking a sine wave and rectifying it into DC voltage, the perfect scenario would be that you have a straight line. But the fact is, as you're rectifying and smoothing and all that kind of stuff, you're still going to have some up and down, and that's called the ripple. There's some other lines sticking out here that are noise, and that's kind of a different characteristic. But in a perfect world, this would basically be a straight line, and the amount of variance in that line is the power supply's ripple, and the less the better. Now, we've sort of established in the other video that at 12 volts pulling 2.5 plus amps, we were getting a ripple of somewhere between 16 and 23 millivolts, which is pretty dang good, especially compared to the ATX power supply. And so what I was sort of wondering is this ripple on this one here any better than the benchtop power supply than I already had? And to be honest, I have no idea, so we're going to go ahead and test it. And while I'm doing that, I'll show you how I'm setting up the scope to detect that. So we're going to bring this up to 12 volts here. And you can see we are pulling 2.6 amps, And where this thing says it should be putting out, it says it's in constant voltage mode. It should be putting out 12 volts. It is only actually putting out 11.874, where this one, when we did the same test in the last video, it was putting out within 1/100th of a volt of what it said it should. So now that we have that turned on, we are going to let the scope run a little bit, and we are going to capture just a snapshot of what we have there. So let me explain how the scope is set up. We have channel 1 going to the positive side and the ground going to the negative side. And we have the trigger menu set up to capture the edge with an AC 50 source. And over here on the channel menu, I have it set to AC coupling with the 20 megahertz bandwidth limit on, and we are set to coarse voltage per division, volts per division, and we have the probe set at 10x. So what we are going to do here is we are going to set the cursor to get roughly the top and bottom of this wave. Now, the noise that you're seeing above and below the wave is somewhat noise from the power supply, but also noise from my setup. So I'm not judging the thing by that noise. So we're gonna go ahead and get our start cursor, which is gonna be at the bottom. And we're going to go at roughly the bottom of that wave that came out. Now again, this should be a straight line. This is DC voltage, direct current. But as you can see, there is some ripple in that. So now we're gonna go to our end cursor, and we're gonna get roughly the top. We're going to give a little bit of the benefit of the doubt. We're going to get roughly the top of the wave. You can see we're a little below there, a little above there. And we are putting out 28.4 millivolts is our variance, is our ripple. So this cheaper power supply is not as good as this one, but still way better than the ATX. Of course, you also do have to factor in the fact that it's not actually putting out 12 volts like it should, where this one was actually putting out 12 volts. For those of you who didn't see the first video, I've got the test set up exactly the same way. Same light bulb, same 12 volts, same 2.6 amps, except this time, instead of getting 11.8, 11.9 volts, the bench meter says that we are putting out 12.001 volts, and we have our wave that's a lot closer to a straight line here. So we're going to go ahead and grab a sample. We're going to increase, we'll leave our volts per division where it is, and we are going to set our cursor. So we're going to grab kind of the bottom point of that line. So the end would be, well, the end would be the top, so we'll grab that. Then we're going to come down here and we're going to hit this, and we're going to grab the start, which will be the bottom of the wave, which I would say is right about there. And we're at 15.2 millivolts per division. So still about twice the ripple on the cheap power supply as the nicer, more expensive Circuit Specialist one. The final thing that I hadn't tested on this was the current measurement. It says it's putting out 2.48 something. This one's saying 2.495, so not exact, but pretty dang close. I've also seen something online where that's actually adjustable. There's a pot that can be adjusted on this thing to adjust the current reading, but I mean, for my purposes, 497, 490, you know, years makes no difference. Okay, so let me give you my final takeaways. This power supply runs currently about $260 at circuitspecialist.com. They provided it to the channel for free so that we could take a look at it. Something like this is about $80 at Amazon, and the math whizzes among you would say, well, hey, I can get 3 of these for the price of one of these. Maybe I should just do that, and maybe you should. But when it comes down to it, as I use this power supply, I do like the user interface better on this. Every test I ran showed that this was a little bit more accurate. And not only that, but once I took the cover off, I confirmed that basically everything in this power supply is adjustable, which means a year or two from now, when this thing goes out of spec a little bit, you can adjust it and tweak it and get it back to spec yourself, with hopefully without having to send it off to anyone else. And this did not have any sort of adjustability inside of it. Another thing in my shop, this one is incredibly quiet. I mean, basically the same noise as ambient noise, and this thing sounds like a whirlwind going through it. So there's a lot of different things with something like this. It's more accurate. Every test showed it to be more accurate, less ripple, just a really nice power supply overall. Now, when you look at its other competitors, there aren't a lot of double and triple power supplies on the market. The bigger guys like Rigol and Handtech and all that make them, but they're considerably more expensive, and actually they're less, at least less powerful. So some of the more expensive ones are 3 amps or 4 amps, or the third rail might be 2 amps. So they all lack power compared to something like this. And then there are a few that are in this price range that are other generic brands, but overall, I think it's hard pressed to say that there's anything that's just going to flat out beat this thing at the price. So I think if you were to take a look at something like this is clearly geared toward hobbyists. And something like this begins to get into the entry level of a professional grade instrument, which is pretty cool to have in my shop. Now, in terms of things that I don't like about it, I took the handle off the top because I basically don't think I'm ever going to carry it around like a lunchbox, and it was getting in the way of me putting other things on top of it. It does take up a lot of space, and so if it's going to take up that space, I want to be able to put something on top of it. There's no vents that I'll be blocking or anything like that. I filled these holes in with epoxy from the bottom, put a piece of painter's tape over the top so that nothing would get in there and fall in. I actually did the same thing on this one when I did the teardown. Overall, the other things I would say is I wasn't thrilled with the leads that came with it. I appreciated that it came with 2 sets of leads, but you know, these are just a couple of wires that have been torn apart and had some leads stuck in them. I appreciate they give them to you, but I'd like to see something like silicone leads or something like that with it. But again, happy to have them. And last but not least, the manual, I would say it's just okay. There's not really a lot you need to know, but there is some important information in here. For instance, it tells you that, you know, for long periods of time, you don't want to drive the linear power supply at more than a 60% load. I wouldn't have known that without having the instruction book in front of me, and I have a friend who killed one of these power supplies running it probably somewhere in that range. And so, you know, there is important information in here. I'd like to see it translate a little bit better. I'd be happy to help with the translation if that's something they need. I do that for a lot of times when people submit things to the channel. I give them free native English translation. So anyway, overall, I would definitely consider it a buy. I am very honored to have this thing in the shop. It may not be for everyone. It may be a little high-endy for some people. But if you can afford it and you want it, I think it's definitely worth getting. So, hey, let me know what you think in the comments. And yeah, thanks for watching. Have a great day.